Right, so today we're going to be writing equations in slope-intercept form. So now we're going to be having the graph of the line, and we're going to have to write out what equation it was before it was graphed. So for A, I'm just going to give the 2 points, and then you can just connect them and make this straight line. So for the first example, I'm going to give you the point 0, 5. And the other point would be 2, 2, 2, 2. And so the line would look like this. Okay. And so now what we're going to do is you're going to write it in this form. And the boxes means I'm going to have to fill this in with my slope, fill this in with my intercept. That is the standard form of a line. So for that, we need to find the slope and the intercept. Well, let's find the intercept first. This is the y-axis. The location where it's intercepted is here, which is 5. So our intercept is going to be 5. Now if you're going to look at the slope, and you look at, let's say this was the path that was taken. So if you were here originally and you got to here, what path did you take? You went down, which was 3 blocks. Now remember, negative means you went down, or down means negative direction. And then if you went to the right 2, that's a positive 2. And remember, your slope is your change in the vertical divided by your change in the horizontal. Change in the y over the change in x. The y changed by negative 3, and the x changed by 2. So our slope is negative 3/2. Let me write it over. And that is the equation that where that line came from. Now B says to write the equation of the line. And the line we have has 2 points. This is your x and y axis. The first point is 3, 2. And the second point is 0, negative 3. And so the line that goes through that point, and we're trying to find the equation for this line. And it's important that they gave us those 2 points because it helps us find our slope between there. So we're going to fill in the general form of an equation, which is y equals mx plus b. And I left the boxes because this is where our slope is going to go. This is where our y-intercept is going to go. And again, remember, b stands for the y-intercept. So let's take a look at the y-intercept first. This is our y-axis, and the place where it intersects is right here at negative 3. So when I have a 0, I already know that's on one of the axes, and since I have my y value, that's going to be my intercept. So we'll just make a note over here. My y-intercept is negative 3. And now to find my slope, remember the slope is the vertical change divided by the horizontal change. So it doesn't matter what point I start on. I'm going to go up. That's 1, 2, 3, 4, 5 up. So that's going to be a positive 5, the difference in the y. And then I'm going to go to the right 3 units. That's a positive 3, the difference in the x's. So my slope is going to be positive 5, positive 3. You could have used the points slope formula. It would have been 2 minus negative 3 and the denominator would have been the x-coordinates, the difference in the x-coordinates, so 3 minus 0. And you notice this equals 3, and this, when you add the opposite, you get 5. So you could have also used the slope formula. But since we have a visual, the graph, it's easier to count the vertical change and the horizontal change visually. All right, so there we go. Now we just put those in the right place. Y equals my slope, which I found was 5/3, x plus, I could put plus a -3, but in algebra we usually don't, so we'll just leave it as -3. Again, if you want to add the opposite, it's not proper to put two symbols next to each other mathematically, so if you are, you can also write it like this. That's the proper way. If you want to write the negative and the addition, it would have to have a parenthesis. So either of those are correct. All right, so let's look at example 2. And in example 2, write the equation of the line. And I'm going to give you a line that's completely horizontal. At 4. 1, 2, 3, 4. So this point would be 0, -4. And the other coordinate, 1, 2, 3, would be -3, -4. So given these 2 points, I'm going to use the same thing. I was here at home on Y Boulevard in my house, and I traveled to this point here. What was the path taken? So we're going to fill in this equation. Mx plus b. In the past, I believe we did recall just writing the equations of horizontal and vertical lines. And this one, you notice the y-coordinate is -4. This is actually the line where every single point has a y-coordinate of -4. So since it's crossing the y-axis at -4, and all the y-coordinates will always be -4, that is actually the line y equals -4. Okay, but let me show you another way of coming up with that line if that's hard to remember. Just go back to the basics. So we have our home, which happened to be here. The address was -4. And then I still have my x term. So what's going to be the m? Well, again, if you're traveling from here to here, what is your horizontal change? Did you have to go up or down to get to this point? The answer is no. So you had to go 0 distance, up and down. But did you have a horizontal distance? How far did you go horizontally? That's 3 units to the left. 3 units to the left, so it's -3. That slope, 0 divided by -3, is still 0. So therefore, when I plug in my m, slope of 0, 0 times x is 0. Any number times anything, 0 times anything is 0. So this actually becomes y equals, that's gone, -4, which is what I mentioned over here. All right? So again, rule is the same. Start off with your intercept on the y-axis. What was the path taken to the other point? Record that down as your slope. If you remember the shortcut for strictly horizontal and vertical lines, crossing the y-axis at 4, it's y equals -4. If it were to be vertical, completely vertical, no slant, then you would say it's x equals wherever it would be crossing. Say if it's here, it would be the line x equals 2. All right, so let's look at example 3. All right, so example 3 is about parasailing. Parasailing is, It's kind of like being pulled by a boat over the ocean on a with a parachute type of thing, and you're just hanging and the boat's pulling you, gliding through the air. So let's say you have this data here. And it's telling you every second that goes by, 1, 2, 3, 4, 5, 6, 7, 8 seconds. And this is going to represent the height, feet in the air. All right, so as the boat's pulling you, you go up into the air and you glide around the ocean. So this would be 10 feet, 20 feet, 30, 40, and 50. So it goes by fives. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And we know that at 45 feet, you have an intersection there. And you have another coordinate at 2:25. 2 seconds, you are 25 feet in the air. I just continued the same path so my line is straight. So I just noticed that it went down 4 over 2 when I got to that point. So I just did it again. Down 4 over 2 and I got to this point. All right, so let's label this one. In 2 seconds, you are 25 feet in the air. In 0 seconds, you are 45 feet in the air. So, question is, we want to represent what's going on with an equation. All right, so we want an equation that shows you the amount of feet that are left. Or obviously you're coming down after X seconds. So at 0 seconds, you are in the air. And as time goes by, you're getting back closer and closer back to the boat. So, and for B, how long does it take to land back on the boat? All right, so we're starting you off. Let's say someone's timing you. You're in the air, and how long does it take you to come back down to the boat as you're parasailing? So for the first one, solution A, the equation is going to be the same as before, right? Y equals some value x plus b. In this box, I'm going to put where my y-intercept is. That would be here. This is my y-axis. So the y-intercept is 45. And in this box, I'm going to put my slope. So from this point to this point, I'm going to look at my vertical and my horizontal. I'm going to go down. I said 4 blocks, but the reality is it's really from 45 to 25. What's the change in the y from 45 to 25? That's a decrease of 20. So it went down 20, negative 20 down. And then to the right, that's just positive 2 seconds. So my slope, which is usually the vertical change, which was negative 20, divided by my horizontal change, which is 2, gives me a slope of negative 10. Okay. So negative 10 is my slope, 45 is my y-intercept. Okay, so for B now, it's asking how long does it take to land back on the boat? Well, if you're back on the boat, that means you are 0 feet in the air. So we would like to know when the y is 0, which would be here. And that happens when it's been 4.5 seconds. So we're actually looking for our x-intercept. Recall, the x-intercept is the point where we have an x value of 4.5 and a y value of 0. Now, if that makes sense, because 4.5 is our seconds, which is our x-coordinate, and the 0 is our y-coordinate, which happens to be the number of feet. So when we're trying to find how long does it take to land back on the boat, we want to know when our height is 0, and that happens at 4.5 seconds. So therefore, it takes 4.5 seconds to be back on the boat, or 0 feet in the air. And there you go.